Hi guys, it's Miss Alstrom. How are you guys doing on your break? I hope you got some rest. So kids have been asking for these videos. They're like, where Miss Alstrom? Where are these videos? They have to make them. Okay, so I put up PP 3.1. I will be making PP 3.2 and 3.3. And then good luck on your PSATs that you're going to be taking on Saturday. I will see you Monday or Tuesday, depending on what day you have me. We start off with a B day, okay? Just so I just want to, since I don't have a classroom, I can't put these things up. That's a sign that a student made me. She graduated from art school. There is another painting in Arabic. It says, with hardship comes ease. And then if I pan right here, these are the little kids that keep me company, the Straw Hat Gang, and my 3 Totoros. Some of these my students have taught me. But anyways, enough of show and tell time. Good luck on your PACTs. I will see you PP 3.2 coming up. Yay! So the instructions for the first set of problems was to find, let's see, to find A, F, G, B, G, F, and C, G, F, G. Oh, yikes. And then find the domain of all of them. Okay. So let's get started on the first one. Okay, so the input is going to be the G function. So let's go ahead and of G of X, and this is going to be F of G X, which is going to be, open up that X, and whoops, plus 8, and that is going to be X, and then plus 5. Okay, I'll go ahead and do the domains in a little bit. G of F, X is going to be G, so the F is going to be the input function. No. What am I doing? It's going to be G. F of X is, open up that, X minus X plus 8 is the input function, and then we have X plus 5. Right? It's the same function. Write it this way if I wanted to. Okay. And then let's go ahead and do C, which is going to be G of G of X, which is going to be, just going to use X minus 3 and then minus 3. So it's going to be X minus 6. Okay. Now, let's go ahead and figure out the domain of F. The domain of F is all real numbers. The domain of G is going to be all real numbers, which tells me if any of them are inputted and we create a composite function using any of the inputs, we input that again into the next function, there is going to be no restriction for this whatsoever. Good times, happy times. Okay, so that means for all of this, the domain, I don't want it to be the same color. Let's make it yellow. Domain is going to be all real numbers. Domain is going to be all real numbers, and the domain is going to be all real numbers. There's no restriction whatsoever. You can input anything for X, for function G and function F. La-di-da-di-da. Okay, next one. Okay, so we had A, which was F of G, which equals, now, whoa, that's the input function, so -4, open up that x plus 7. Let's go ahead and distribute -4x minus 28. So f g of x, so f of g of x equals -4x minus 28. Voila. Okay. Let's make it yellow. Okay, B is going to be where f is the input function. Let's open up that, -4x plus 7. And so G equals -4x plus 7. And there you go. That's it. Easy. Okay. C is going to be G of G. Let's open up that and then put x plus 7 plus 7. G of G x equals x plus 14. All linear inputs, linear composites, linear. Okay, once again, let's go ahead and identify the domain of f is going to be all real numbers. The domain of G is going to be all real numbers. When we use either one function as an input into another function, there is no restrictions whatsoever. So for all of these, you know, the smart thing would be to just would be all real numbers. Ew. Domain, oh, that's 2, is all real numbers, and then domain is all real numbers, and domain is all real numbers. Okay, good job. Okay, next one. Let's see. First, A is going to be f of g of x. So g is the input function, so open up that, x minus 1 squared. I mean, you can leave it like that. I mean, hey, it's in factored form, okay? And then B would be g of f of x. And so f is the input function, so that's going to be x squared minus 1. And then C is going to be g of x, so that's going to be x minus 1, which is x minus 2. That's g of x. Okay, once again, let's go ahead and look at the domain of f. The domain of f is going to be, f function is going to be all real numbers. The domain of g is going to be all real numbers. So therefore, the domain of this composite function is all real numbers. The domain of this composite function, note to self, do not use this color. I don't like it. No, I don't want to use the same color. I'll just use this. And domain is all real numbers. Okay? Good job. Number 4. So A is f of g, x. G is the input function, 3x to the 4th. B is g is x, so that's going to be the input function, so 3x to the 4th. We have to we can simplify that. So that's 3 to the 4th, x to the 4th. 3 to the 4th. 3 times 3 is 9. 9 times 9 is 81. 81 x to the 4th. And then C, g of g to the x is going to be x to the 4th raised to the 4th power. We multiply the two exponents together. X to the 16th. So if we look at the domain of f is going to be, that's a linear function, all real numbers. The domain of g is going to be, that is an even function. It's gonna look like a parabola, but anything could be x. You can put anything for x, so that's gonna be all real numbers. So the composite function is going to be, the domain is going to be all reals. The domain of this is going to be all reals, and the domain of this is going to be all reals. Okay? Good job. Okay. Number 5. First, A, so that's f of g of x. So g is the input, so cube root of x cubed plus 1 minus 1 is going to be equal to the cube root of x cubed, which is just x. That's f g of x. B, we'll get g of f of x. So now that's going to be the input. So we have a cube root of x minus 1. We're going to cube that, add 1. Cube rooting something and then cubing, that's just itself. Okay, another way to think about that is that's x minus 1 to the 1/3. When you raise that to the 3rd power, it just equals 1, just one of that. Plus 1, so that's going to be x. Oh, they're inverses. Okay. F of x. Now C is going to be g of x. That is going to be, open that up, x cubed plus 1 cubed plus 1. Oh, we're going to have to do some math. So x cubed plus 1 times x cubed plus 1, x cubed plus 1 plus 1. So that is going to be x to the, so that's going to be x to the 6th because it's x to the 3rd times x to the 3rd. In that case, we add the exponents, and then that's going to be plus x cubed plus x cubed plus 1, and then multiply this by x cubed plus 1 plus 1, and that's going to be, let's go ahead and simplify it, x to the 6th plus 2 x cubed plus 1 x cubed plus 1 plus 1. Okay, and then I'm going to take that and let's go ahead and finish up here. So that's going to be x to the 9th. And we take that x to the 6th right here, and so x to the 6th times x to the 3rd. We add the exponents to the 9th, and then it's going to be x to the 6th times 1. So that's going to be plus x to the 6th, and then we're going to take that 2x cubed and we're going to multiply it to x cubed. That's be 2x to the 6th. This is going to be 2x to the 6th. I'm running out of space. And then we're going to take that 2x to the cubed, multiply it by 1, 2x to the cube, and then we're just going to take plus x to that, and then plus 1. So and then plus 1. So that's going to be x to the 9th plus 3x to the 6th plus 3x cubed plus 4. I think I made a mistake. Okay, so x to the 9th, x to the 6th came from there. I don't know where that plus 2 came from. I have no idea. So I'm going to erase that. And then 2x6 plus 2x. Yep. So it's not going to be plus 4. It's going to be plus 2. Okay. So that means this equals g of x. So let's go ahead and look at the domain of f. Now, domain of f is a cube root function. If you know anything about cube root functions, x could be anything, even a negative, because the cube root of a -1, what number multiplied by itself 3 times gives you -1? That's going to be -1, -1 times -1. And that works because that's a cube, and it's not an even. Okay. A cubic function is also all real numbers, so there's no limitations on this. So the domain of this is going to be all real, the domain of this is going to be all real, and the domain of this is going to be all real. Okay, good job, guys. Okay, number 6. So A, we are going to find g x. So f is going to be, function g is going to be my inputs. And so that means 1 over x is my input, and f of g of x. If I use my exponent properties, that's the way it's going to look. So f of g of x equals 1 over x cubed. B is going to be where the function f is the input. So if I input that into that, that's that. And then C would be g x is 1 over x, which would be 1 divided by 1 over x, so 1 times x. So that's g of g x equals x. Let's go ahead and state the domain of f is going to be all real numbers, since it's a cubic function, but the domain of g is x cannot be equal to 0. Okay, so we have to, it's a case-by-case thing where we have to look at each of the functions and see where the input is. Okay, because we know that here x cannot be equal to 0. Okay, so if you look at A, where g was the input function, then what can we not input from the beginning, beginning of the composition of function? Okay, and that is x cannot be equal to 0. Okay, initially, from the beginning, when we put in 0 into this function right here, g0, we get an undefined. Okay, so depending on which function is the input function, then we know that initially that x cannot be equal to 0. Okay, now if you look at the second one, f is the input function. So for f, it could be all real numbers. You're still going to get an output. You're still going to get some kind of output. And then that output is going to be the input of this. But the input of this function cannot be 0. Okay, so we trace back. The output became the input. We trace back when we figure out what that input function has to be in order for its output to be 0. So to figure that out, I have to set this function right here equal to 0. So 0 equals x cubed, and cube root both sides. So 0 equals x. So for this, the domain is x cannot be equal to 0. And you can test that. You can test it. Okay? So we have, let's go ahead and use a different color. We have I'm going to use this composition of function. So f of 0 equals 0 cubed, which is 0. Now that is going to be g of 0 equals 1 over 0, and therefore it's undefined. Okay, it's undefined. So yeah, x cannot be equal to 0. Okay, for this one, if you take a look, the input function was x cannot be equal to 0. So the domain is going to be x cannot be equal to 0, and then that's going to be undefined, and then the actual output of that is going to be undefined. So there's really nothing that you could do. It's just x cannot be equal to 0. Okay. That's it. Okay. Good job. Next one. Okay, so A, there was a different set of instructions. They just asked for F, G, and G, F, and then find the domain. So let's see, G of X is going to be, input function is going to be that, plus 4. And that's the way it's going to stay. I mean, if somebody out there thinks this is x squared plus 2, no. No, because if you square this, okay, it should look like the radicand. It doesn't. Okay, that's not how that works. Now, if it was x plus 2 squared and then square root that, then it would just be x plus 2. But once again, there's this, that is the final answer for that. And then B is g f of x. So f is the input function. So now we're going to take the square root of x plus 4 squared. That's it, right? That's the output. And then, yeah, g of f of x equals x plus 4. Okay, let's go ahead and determine the domain of f. Domain of f. So x plus 4 has to be greater than or equal to 0. So x has to be greater than or equal to negative 4. And then the domain of g is going to be all real numbers. So now we have to look at the domain and range. Okay, so of the input function here, g is the input function. Okay, and that's going to be all real numbers. Okay, so this is going to be all real numbers for the input or the domain. Yikes. I want to write it here. Domain is all real numbers. Let's look at the range of this function. What's the output of this function? The output of this function is, it's going to be all positive and 0, right? Or you could write it as y is going to be greater than or equal to 0. Okay, so if you look at, and that range is now going to be turned into the input. I'm going to go ahead and write it so that it'll save right here. Okay, let's go ahead and talk about that again. So for function function f, it's going to be all real numbers. And then the range of function f is going to be y is going to be greater than or equal to all real numbers. If I take that, whatever comes out of this function is going to be all positives and zeros of the real number. And if I understand that, the domain of g, remember, or domain of f, oh, I'm sorry, this is going to be g. This is going to be g. Okay, and then if you look at that, the domain of f, okay, has to be greater than or equal to -4. But the output of the function g is already going to be greater than or equal to -4, which tells us that the domain of this composite function is going to be all real numbers. If you understand this range of that parabola, then you understand that input, and it could be used any of the inputs. Okay, now let's go ahead and figure out the domain. So the input function is already going to be restricted. X is going to be equal to -4. Okay, which tells us that since that is the input, that's what you started off with, and those are already going to be restricted with that input function of f, so the domain of the entire function is going to be all real numbers. X is greater than or equal to -4. Okay? Next one. Let's take a look. So we have A, that's f of g of x. There's the input. So that's at x to the 2/3. And then we're going to open that up. So x 2/3/3. We multiply the two exponents. That's going to be x to the 2nd. And then b is going to be g of f of x. Open up that. X cubed, x to the 2/3, which is also going to be g of f of x equals x to the 2nd. Okay, so let's go ahead and state the domain and range. Domain of g is all real numbers, and domain of f is all real numbers. And so there's no restrictions. So this is going to be domain of all real numbers, and this is also domain of all real numbers. Okay, next one, number 9. A is going to be f of g of x. So that's the input function. So open up the absolute value sign. There we go. Easy. And then g of f of x. So open that up. Okay. Let's go ahead and some restrictions. The domain of f is all real numbers. The domain of g is all real numbers. So once again, no restrictions. Domain is all real numbers. Domain is all real numbers. Good job. Next one. A f of g. Function g is the input 1 over x plus 3. B g f. F is the input function, so we're going to have 1 over x plus 3. And you can write it this way, or if you want to write it as 1 plus 3x over x, it's up to you. Okay, now let's go ahead and figure out the domain of f. X cannot be equal to 0, and the domain of g is all real numbers. Now let's go ahead and look at A, the input was g, this was the input. Input function was the g of x, which was all real numbers, so any number could work for it. But f of x, x cannot be 0. So if that produces a 0, then it cannot work for f of x. So therefore I have to figure out this output of g of x. So I set that equal to the original function of g of x, the output of g of x. Okay, if it's an input. So x equals -3. So the domain of this is x cannot equal -3. Okay, now for the next one, if I look, initially we can't have x being equal to 0. So the first function, which was f of x, the input function, x cannot equal 0. So the domain of this would be x cannot be equal to 0. And it kind of coincides that that would be the domains of the composition of functions if you take a look at the denominators. Okay? Good job. This one's a little tricky. Okay? Your favorite, f of g of x, we had 2 over, and then we're going to make 2 times 3 over x minus 5 plus 4. Okay, 2 over, that's going to be 6 over x minus 5 plus 4. And this is going to be 2 over 6 over x minus 5. Common denominator is x minus 5, 4 times x minus 5 over x minus 5. And then that is going to be 2 over 6 plus 4 times x minus 5 over x minus 5. And then that is going to be 2 over 6 plus 4x minus 20 over x minus 5. That'll be 2 over 4x, is it minus 14 over x minus 5. That turns into 2 times x minus 5 over 4x minus 14. So that is going to be a 2x. I'm going to distribute that 2 minus 10 over, or 4x minus 14. I think I can simplify this. That's a x minus 5 over 2x minus 7. So that's going to be the f of g of x. Okay. Oh, that was long. Now let's go ahead and figure out g of f of x. So g is my input function. There is my input. 2 over 2x plus 4 minus 5. I can go ahead and simplify this function and that function inside. And f of x is not simplified. Okay, but you know, we'll just keep it this way. And then 2 over 2x plus 4 minus 5 times 2x plus 4 over 2x plus 4, and 3 over 2 minus 10x minus 20 over 2x plus 4, which equals 3 over negative 10x minus 18 over 2x plus 4. And that equals 3 times 2x plus 4 over negative 10x minus 18, which is a, distribute the 3, so that's 6x plus 12 over negative 10x minus 18. I can take each of the terms. They're all divisible by 2, so that's going to be 3x plus 6 over minus 5x minus 9, and that's g of f(x). Okay, let's go ahead and state the domain and range of this. Okay, so the domain of f is that 2x plus 4 cannot be equal to 0, so x cannot be equal to negative 2. And then the domain of g is where x cannot be equal to 5. Okay, so if I look at a, where g was the input function, okay, if g was the input function, so first right off the bat, we know that for the domain, if g was the input function, we could use this domain right here. X cannot be equal to 5. And then we figure out that after we put it into, if we put in the function g into f, its input, okay, input of f cannot be negative 2. Now that input of f has to come from the output of g. So what I'm going to do is take that negative 2 and set it equal to g. 3 over x minus 5. And then that's going to be a negative 2x plus 10 equals 3. That is going to be negative 2x equals, so what is that, negative 10, negative 7. So x equals 7 over 2. And so it also cannot be equal to, x cannot be equal to 7 over 2. And I can try. I mean, I can go back into here and I can try, but the problem is so far away from the answers. Oh, what am I gonna do? Okay, so I can have g be 7 over 2, and then that's 3 over x minus 5, 3 over 7 over 2 minus 5. Okay, and then g of 7 over 2 is going to be 3 over 7 over 2 minus is that 10 over 2. So that's g of 7 over 2 equals 3 over negative 3 over 2. So g of 7 over 2 equals 3 times negative 2 over 3. So g of 7 over 2 is going to be equal to negative 2. Now I'm going to take that and I'm going to put it into f of x. So f of negative 2 is going to be equal to 2 over 2x, 2 over 2 times negative 2 plus 4, and f of negative 2 is equal to 2 over 0, which makes it undefined. So that checks out. Okay? Now, let's go ahead and do B. B, right off the bat, we know that if I look at the input function was f of x, so that's going to restrict my domain. It cannot be negative 2. Now, let's do this in a different color. The input for g of x cannot be 5, which means the output of f of x cannot be 5. So if I take that f of x, 5 equals 2 over 2x plus 4, and that would be, if you left an answer like that, unsimplified, that's wrong. Okay, I'm just letting you know. It should be 1 over x plus 2. But anyways, okay, 10x plus 20 equals 2. So that's 10x equals negative 18, and x equals negative 18 is that negative 9 over 5. Okay, so that means that the other domain for this is x cannot be equal to negative 9 over 5. And I could test it again. I could make my input function for that was g. So g of negative 9 over 5 is going to be equal to 3 over negative 9 over 5 minus 5. Okay, so that's going to be 3 over negative 9 minus 25 over 5. So that's going to be 3 over negative 34 over 5. Something is not right here. Let's see. I used the wrong input function. Whoa, whoa, whoa. Okay, it happens. Okay, and so let's go ahead and do f of negative 9 over 5, which equals 2 over 2 times negative 9 over 5 plus 4. Okay, so f of negative 9 over 5 equals 2 over, that is negative 18 over 5 plus 20 over 5. So f of negative 9 over 5 equals 2 over 5, which equals 2 times 5 over 2, which equals 5. If I put that into g of x, just set 3 over, it doesn't matter what the numerator is, 3 over 5 minus 5, which makes it 3 over 0. So once again, it makes it undefined. So I know that those are the correct answers. And if you actually look, okay, hey, isn't that the restriction on the composition of functions? And right here too. Hey, anyways, okay. Good job, guys.